Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. Hi, everyone, and thanks for joining the MLOps podcast. I'm Dean, your host, and today I have Lee Harper with me. Lee Harper holds a doctorate in physical and theoretical chemistry from Oxford. He is a teacher turned data scientist with vast experience in the industry, building end-to-end data science platforms, working on computer vision and productizing machine learning models. He's a principal data scientist at Catapult Systems, where he leads and architects data science and machine learning projects for various clients. So Lee, thanks for taking the time to join me today.
Oh, I'm glad to be here.
Awesome. So let's start from the top. You have a really varied background, and I'm really curious to know how you got into the fields of data science and machine learning. Were there any specific challenges that you faced?
So I kind of fell into the field by accident. As you kind of mentioned in your introduction, I used to be a teacher. So I did my Ph.D., enjoyed the teaching part of that, and so went into a high school in the UK for a while. And teaching is a really hard job. If anybody claims otherwise, they have no idea what they're talking about. And I kind of actually ended up burning out quite badly in that job. So then I was looking for what job can I just go and do that isn't going to be super hard for me. And there was I've got the research and math background, so that kind of made sense. And so I kind of was looking at jobs locally in the area that I was living in, and there was a company who was looking for a spectroscopist, which is what I did my PhD in, who also knew some stats, which I know some stats as well. Great. So apply, got the role. Turns out, unbeknownst to me, it was actually a machine learning research position. Or that's what we ended up using those techniques to solve the problems that we were trying to address. So I say, kind of got into it really by accident, but obviously when I did, I was kind of like, oh, cool, I'm doing machine learning now. That's cool. And this is back in 2013. And I guess I hit the rising wave, so to speak. So it kind of been good for my career to kind of hit it just at the right point. So challenges that I faced. So the main one is back in 2013, things I think still weren't really standardized around R and Python like they are nowadays. Mm-hmm. So actually, I was doing all my machine learning in Fortran and MATLAB, writing all my own algorithms, or pulling down people's custom ones from MATLAB Central and modifying them myself. So I moved to the step. Oh, and I also didn't know SQL because we had our own query language that we developed for our data, because we're using encrypted binary streams. That was our data, was just binary streams, the computer vision model for compression reasons. And so I moved here to the States in 2015, and I didn't know Python, didn't know SQL, so all the kind of normal tech languages. So I had some roles that were kind of not quite what I wanted, but I realized I had to upskill myself to those things to get the roles that I wanted. So I actually went back to school, did one of the boot camps, really to acquire those skills. Perhaps wasn't the most average student there, right? Because I came in knowing a lot of the machine learning theory stuff. But that was really good for me. I've had lots of time to learn SQL, Python, get good at them, and then I've been going from there. So the main challenge there is to make sure that you remain current on all the latest technologies that people actually want, rather than kind of being in your comfort zone with what you already know. And this field, I think, more than most, that's really applicable to.
Yeah. I think that first, you might be the first time I've heard someone being sort of air quotes, duped into a machine learning role. It usually happens the other way around. Like you get into a non-ML role and gradually try to convince your boss to make it more ML oriented. So that's interesting. And then I guess one maybe this is a controversial take, but that's interesting. So boot camps and things like that are always brought up as sort of a way into the field. And it seems like part of the reason that that's a way is because a lot of people don't come in with the background skills, and it might be sort of a more concentrated way to get them instead of going into a full-blown like university degree, research, etc. But then you maybe are an example of someone who came with the maybe the harder skills to get, and you went maybe to the boot camp to acquire the skills that are I don't know, maybe more high level or maybe more practical. Sorry, not more high level. So like the programming itself and everything. Do you feel like that, like, how do you feel about boot camps in general if someone is a beginner right now and wants to get into the industry?
Yeah, so I've hired or been involved with hiring people from both boot camps and from degree programs, right? So I've kind of and I've mentored people from both backgrounds. Mm-hmm. And what I've generally found is this. So one, if you have a bachelor's degree and you want to do data science, go and get a bachelor's degree. Okay. Mm-hmm. You know, if you're 18 years old and want to get data science, that's what you really need to go and do. I've known people that haven't done that or try to transition in without a bachelor's degree. That is hard just because companies really want masters and PhDs, but they at least want to see a bachelor's degree. And mm-hmm. whilst you may not, and if you don't know calculus and stuff, that's kind of an issue, right? At least those basic mathematical foundations. But what I've found the difference between people with let's say master's degree or PhD versus boot camp, the boot campers arrive work ready. Okay, so they don't have maybe the background in the theory as strongly. They don't have background in the math as strongly, but they're better at coding in general. They're better at the libraries in general that are used as standards. So they're often much faster to get going in a, let's say, corporate environment, a non-research environment, right, mm-hmm. where we're doing very much of the applied machine learning side of things. The people who come from the master's degrees of PhD programs often have either niche skills, which can be very, very valuable somewhere. Like there are certain roles that you absolutely want someone with a research background to fill, mm-hmm. right? That's a requisite. Some of the more advanced, let's say autonomous vehicles, right? Mm-hmm. Really, you need to have a background in that to go and work in that because it's so specific and it's so detailed, and you can't even make headway in it unless you have that really good mathematical foundation. But often they come in, and because they haven't been trained maybe to write production level code or even to be even taught to code, a lot of these degree programs don't really teach coding outside of the basics of how to do some code. Mm-hmm. So often there's a lot more work to do with them, less work on the theory side, but more work on the writing usable code side and debugging more of the, let's say, more practical issues with code. So both sides have pros and cons with them. And what I like about having a mixture of both, though, is you also get a larger diversity of backgrounds as well. And I think that's a great way of combating bias in the field. It's a great way of just having people ask questions that, maybe I, as a, white British man, wouldn't think of asking. Right, but I bring in somebody, who's, from a very different background to myself, and they ask us different questions. One of my team members is a BA by training, right? And she's moved to data science to the master's degree, but she brings this amazing BA background, so she's amazing at just like hearing subtext in what people are saying, right, and just unpicking that, both what's said and what isn't said. So that having any way of increasing the diversity of backgrounds in the field, I think, is a good thing for the field as a whole.
Yeah, I think data science is one of the rare cases where you actually, it's not just in theory, you actually have people coming in from any background you can imagine, and somehow they found themselves in data science. So you have, I would argue, a significantly larger chance of working with people that have a very different background than what you have. And that's awesome. That's an opportunity, and you should definitely embrace it when and if you can. So I guess in your first role, writing in Fortran and everything, like what was there production? How did that look? How did that change over the years until today?
My first production model, and I'm going to put production in quotation marks. They're very strong here, right? So I've just made comments about people coming from academia and their coding skills. I would class myself from there. Like I've been coding for 5 years in academia, but very much coding for my own projects for mathematical computing, not for application development or anything of that nature. And so I find myself here having to do my first model. I've got it built. I'm ready to send it out to our partners. We have various academic partners who we worked with, and they're the ones who are my consumers of my model. Researchers in medical science departments around the UK. So the question now is, okay, well, how do I push this out for something that they can use? So I was in MATLAB and Fortran, neither which are known for good application development processes. I also had no cloud, right? So no Docker, none of that sort of stuff. So everything I had to run on a single computer. I had to actually email someone or send someone the installation, the .exe installation via a secure share or something, right? So that again limits our options significantly in how we can push out updates to people. And so I ended up building a system that worked, but it was very much one of these things whereby if you wanted to do, I didn't know how to decouple, say, training from inference time. Right, so if you want to do an inference, you had to retrain the model. Right, it was a full end-to-end process. Right, I didn't really have the skills at that point to be able to separate out, or even do abstractions. Right, so to be able to separate out, my serving, whatever my serving layer looked like from my backend layer. And it was all in one go. My user interface was the same code as the model training side of things. So did it work? Well, yeah, it kind of worked. Was it maintainable? Not particularly. Like I had a Git repo on my side, but nobody else could pull that down remotely. Was there any MLOps? I guess MLOps wasn't even coined back in 2013, right? 2014. So deeply painful. It took me 6 months to after the model was ready to get it out into the hands of the users to the point where it actually worked. Again, a story that we kind of quite commonly hear, right? It could be 6 months to a year to deploy the model. Yeah, that was my first model to be that long to get out and deploy. I've been guilty of that as well.
I guess that's fast compared to the time though. Like many organizations still take 6 months to deploy a model. So that's impressive. You were ahead of the curve.
Maybe, but yeah, it was definitely not pretty from the point of view of getting that out. But also it was a learning experience as well. I hated it. Right, it was a bad experience. 6 months making incremental progress was not overly fun, and it kind of did get me thinking at the time. Well, there must be a better way of doing this. So it was a bad experience in some ways, but also kind of a formative experience as well. Like I don't want to have to do that again.
Yeah, I mean that's how the best products are made, right? Like you suffer something personally, like the world shouldn't work like this, and then you build it, and everyone uses it, maybe, or at least that's the canonical story. But then I'm curious, like, do you feel like the major shift has been from those maybe older languages to Python and R, which are more widespread, more standardized, and something like that? Or was there a point where you could say like something has changed here and production for machine learning looks like fundamentally different right now?
So I think a few things have changed, and I actually don't think it's Python and R in of themselves that are the key drivers here, because even looking at MATLAB, I haven't used MATLAB now for, since that job I had, right? Haven't used it in 6 years, but I still look at it and keep track of how it's evolving. And they now even have MLOps kind of functionality within MATLAB now, right? So I feel it goes beyond Python and R. I think the main thing, there's kind of two main things for me. So one was going from being purely on-prem one machine to being in the cloud. Well, now we have natural ways of sharing and collaborating, right? We can create one cloud environment that multiple people can work in, and also empowers microservice architectures, which makes separating out your different layers of your system much easier, right? I can have my machine learning microservice inference is running here, and I maintain that myself, and the rest of the team maintains everything else around it, right? So that's kind of one piece of the puzzle, kind of that. And I think then the thing that's really evolved in the last maybe 2 to 3 years is the emergence and evolution of actual platform services. So even 4 or 5 years ago, if we wanted to deploy something, it was still pretty painful. Right? We had to be able to build a container, deploy it to Kubernetes, probably bare metal or something else, which meant you had to learn Docker, you had to learn all these bits and pieces, which a learning curve there. Whereas now you can come in and you've got Azure ML, you've got SageMaker, you've got other kinds of platforms from third parties and startups that are kind of trying to solve this problem, which almost mean you can now deploy to containers or microservices almost without having to know Docker. Or it always helps if you know it, and you can extend things out. But containers and other things like that mean that you can just deploy things via APIs now and build that into your MLOps workflow if you want to, rather than having to build things from scratch. It depends on what you're doing. But that means that I can get a new model now, and I can potentially deploy a new model to a pseudo production environment in a matter of hours.
And do you
rather
think
than it taking months or weeks?
Yeah. Do you think that's sort of the common use case, or not the common use case, but the common timeline right now? Like, or if not, what's again putting you ahead of the curve?
I mean, I've done enough times now, and at Catapult we've actually built out our own templates and solutions for this, right? So yes, we've put hours into it, but we've also extracted out the commonalities between projects, so that also accelerates things substantially. I think one thing I noticed about data science teams is this love of reinventing the wheel. I don't know if you've encountered this yourself, Dean, at various things that you've seen and worked with, but there kind of seems to be I've seen a number of teams try and build out a model from scratch. Well, that model already exists somewhere else, right? Someone's already built that model. Why don't we just pull that model in? Or even writing their own libraries for things that already exist in at Conda or PyPy that work perfectly well. And often it's not because they didn't want to use it; they just didn't even know it existed. And so I think that's often the case. I see a lot of people, Catapult, we're Azure users, right? We do a lot of it in Azure, but obviously other platforms have their own versions as well. Azure ML, which is their ML platform service, is really quite good for doing a lot of things pretty efficiently. A lot of data scientists in Azure don't even know it exists. Or they haven't ever looked at it. They haven't taken the time to go and look at it and see how it could improve their workflow. Or, pick any third-party service, right, that could improve parts of the workflow. Like, they just haven't taken the time to go and explore that and see how it could help them. So I think that's also part of the reason why we're seeing, still groups taking, even today, a year or more. I've heard horror stories to get to production. And I'm like, well, I don't feel that should be the case anymore, because the tools do exist now to accelerate a lot of these processes. Outside of, if you're Google, Facebook, Tesla, with the latest, greatest, highest throughput models in the world, sure. But then I almost go to that they are faster than a year to get things deployed, right? Because they have the MLOps in place as well to enable that across their organizations.
Yeah, I think that really makes sense. And we sort of mentioned this a lot. I think that it's interesting that people want to reinvent the wheel. But on the other hand, it obviously makes sense. And I'm curious if you think that this is more common in data science compared to maybe software development, because people come from a scientific background more often than not, or something else.
I think so, because I know. So to give you a kind of a story here about, in my Ph.D, I did a lot of work with lasers. So I did a lot of spectroscopy, and so we had various fiber optic arrays that we used to use to guide our lasers around the lab and to the right locations that we needed to use them in. And we had cheapo arrays, right? Ones that cost maybe £100. Took sometimes weeks to align them properly to work, and then they wouldn't always hold their alignment very well because we were grant funded, right? We always had this poverty mindset that we couldn't afford something better. When I went to Renishaw, where I was doing my first machine learning role, I remember my first day interview going around some of their labs, and they actually asked me to couple up with a cable to prove I could, which is kind of a funny thing. But I was like, oh my god, that's the £5,000 like Rolls Royce of fiber optic coupling arrays. Like, wow. And the guy who was my manager, said, yeah, but think of it from my terms, like my people's time is expensive. So if I can save them 2 weeks of time coupling a fiber optic cable in, that's worth £5,000 to me. And I was like, huh. And that was my first time realizing that kind of in academia, we almost have this poverty mindset, right? We can't afford that nice thing. We can't afford that nice package. We can't afford that nice software, or we get credit from on our courses or on our theses for doing it ourselves, right? I could write a whole subsection on how to couple in a cable with these cheapo arrays, right? That was worthy research. So I was almost incentivized to reinvent the wheel. Whereas, suddenly in business, where time is money, I get paid, right? I have a salary. Suddenly all that time saving, even if it costs money to make those time savings, can be very, very valuable, especially given how much data scientists cost, right? In general, we are not cheap employees to have at a company. So I think that's why people do it, because a lot of academia, where we have that almost that poverty mindset in place.
The optics example hits me in the feels. I did research in university in quantum optics. That sounds, a lot of what you said sounds very familiar. And I joke, like the research was on like photonics and stuff like that, but the actual research was on how do you twist the screw of the mirror so it's exactly at the right angle and it actually works. And you could probably write like a peer-reviewed article about that, and that would be worth someone something. So yeah, I definitely understand what you mean. I guess maybe the solution is just to give the industry more time. Like I think this is really in many ways holding us back, and sort of we've had the conversations of like we have this pressing burning issue in production. How would you recommend we solve it? And then there's like a tool. Sometimes it's in the title of the tool that it solves the issue, but sometimes it's like simple Googling or GitHubbing now will get you to that solution pretty quickly. So yeah, maybe in 2 years the world will look a bit differently in that regard. Yeah, sorry, you want to say something?
Well, Googling is, I'd say, the single most important skill in this field. Which is why I'm always surprised in interviews why it's always like, whiteboarding as an exam. It's like, well, I'll just Google this, right? I'd solve it in like 5 seconds by Google and copy and paste.
Yeah, I recommend like the best interview is one where you as an employer put in the hours to think how the job will actually look, and then try to build questions and tasks that actually represent that. But that's harder than Googling for interview questions and then choosing a bunch and then doing them. So maybe it's a two-way issue. So anyway, so at Catapult you're doing work with a lot of different clients, right? And that means that you get exposed to different use cases, machine learning, data science. Do you feel like, again, today there are recurring themes and challenges and sort of common issues that always come up?
Yes, and I think, especially within like the MLOps context, right? Within that, within DevOps, DevOps folks always talk about the fact, DevOps is 3 things, right? It's people, process, and tools, okay, and usually in that order, right? Mm-hmm. So on the people side, I commonly see a skills gap, and this kind of different organizations, right? There's not a universal skills gap per se, but kind of the general themes are you've often got data scientists or people that maybe even citizen data scientists, people who are analysts who've got some tools, some low-code tools to play around with and have built something that's useful. And you've got your software engineering team. MLOps kind of, though, sits in that awkward space between the two, where a lot of data scientists don't have the engineering skills to build a testable, reproducible pipeline, right? Where you can write unit tests, where you can redeploy it, and those sorts of things. And a lot of your software engineers don't have the ML skills to really be able to accurately translate a data scientist's Jupyter notebook into like testable code that will do the exact same things it did in the notebook. Mm-hmm. So you kind of have this kind of that weird skills gap here, where kind of is something that says like, well, that's not me, that's software engineering. So we just like, well, we don't have machine learning to be able to do it accurately. So that's kind of one recurring challenge, is how do we fill that almost like skills gap where the two meet, and no one quite is confident with the whole of everything in order to be comfortable with it. And it does require a lot of people. Like the way that we solve it at Catapult is that we have lots of different people who can fill the different roles, right? And we can also do it partial time. We haven't got to hire a whole DevOps person for that piece. We can have a half a person or a quarter of a person, right, that we bring in on a different project.
Yeah.
And that's part of that is education. And then part of that then moves on to the process, right? How do we enable you to do it? And the biggest challenge there is security, I would argue. Mm-hmm. So a lot of our clients are either large enterprises, or we actually do a lot of work with FinServ customers and healthcare customers who are all regulated, right? So they have rules around information security. In fact, here in the US, we have regulations around that. In fact, you do in most countries, that security has to meet and be compliant with. You have to prove that you can be compliant with that. And that can create challenges for machine learning, whereby you've got, models need data, right? Often you've made different kinds of data from different sources to build a good model in these areas. So how do you enable, even at the start of the project, to get that data from your past security? If you might have stuff that's on-prem behind a Red-Blue network. You might have stuff that's in the cloud or from third parties, all with different security and regulatory requirements. And then when you come to deploy it to production, can get even more challenging, because then you've got to worry about, how do I get my data routinely into my production location so I can keep retraining and doing inference? And also, how do I secure the machine learning model itself? I feel that's an area there's not always enough research around yet. And it's an evolving field, but how do I actually secure my models so that they're compliant with the same as the data and other things that are behind? And then how do I secure my inferences? How do I write those back securely? And that just adds a whole bunch of process complications. But sometimes you've got to do some pretty gnarly things with your MLOps to get past those kind of network restrictions. Or to help educate IT in that, well, yes, the most secure thing to do is to have everything behind a walled garden and no one can get to it. That's very, very secure. It's also unhelpful. You'd be amazed at how many IT teams want to have that happen. Like, oh, we don't want to hurt the data. This is our pod data. It needs to be completely isolated and like there in its silo. And it's like, well, great. That's like unburied oil, right? We do. How do we start trying to dig that up so we can get value out of it? So, and then in the tools front, I think we've spoken about that. It's just education around knowing what's even out there in the first place is the biggest kind of recurring theme there, I see.
Yeah. No, I think that sort of to these 2 points, I guess the main point you're making about security is which, to be honest, is something that I think a lot of organizations haven't gotten to yet, because they don't have models at scale that are running in production. And then once you get to that production, it's basically the starting point, right? Like, you get your first model into production, and then you need to answer questions like, how do I do this at scale? Not with having the bureaucracy of requesting, getting specific agreements to get data to train one model, but this actually has to run over and over, and ideally automatically as part of this production system and everything. I think that's really interesting. And I guess we can get to the tooling in a moment, but I guess in this case, do you think that there's a solution which is relatively generic and can be automated, or is this more of like every organization needs to understand their security needs and just solve it for case by case, basically?
So, I mean, there are some level of genericization possible. In fact, if you go onto Microsoft or Amazon or Google or any of the big cloud providers, right, websites, you will often see, here's our architecture for financial services, here's our architecture for defense, here's our architecture for criminal justice, right? They'll actually often have those listed out, and those are fairly generic, and those are pretty good. The question is whether the organization themselves is happy with that level of security, right? Mm-hmm. And the answer often is they just want a bit more certainty and a bit more of their own stuff, or their own IT team has their own ideas. The cloud is still relatively new, right? There's not, although it is pretty robust, and there's really been any major leaks, if any, from the big cloud providers, other than people leaving their own stuff open to the internet, which is the customer's fault, not the provider's fault. They still want more certainty. Like, they want their own firewall, not just a cloud firewall, or they want to have, everything behind its own virtual network. Well, great, but again, that brings more complications around. Well, how does my machine learning behind its virtual network talk to the data behind its virtual network, talk to the serving layer behind its virtual network? That again creates it can get real complex real quickly. So whilst it can be genericized, some of us are happy with the genericization and do well with that, but others want to go further than that. And the minute you go further beyond that kind of baseline, things can get pretty complex pretty quickly.
Yeah, that's the way I think we're seeing this as well. And I think this is in a sense connected also to treating data as a first-class citizen, because part of these issues are like, well, I know how to handle code in production from a security perspective, but what does data in production mean? It's just like, isn't it just a different database that I'm connecting to, and now it has the real data as opposed to something that I mocked for testing? And then I think maybe in a sense, startups might have an advantage here, because if you're building something which is ML oriented or something like that, then you can treat data as a first-class citizen from day one, and you won't need to build this entire IT organization that handles dev production, but then doesn't know how to handle ML production. But that's definitely a challenge, because usually the other side of that coin is you need to be able to look further into the future. Like usually the first model will not have data security because you built it, like you custom built everything and now it works. So you can push it into production. But then having this mindset of like, we're going to automate this at some point, so we need to make sure that the abstraction makes sense for that is super important. So I agree on that point.
And then with startups, let's say you've got your Series A or Series B, and you're starting to get build a customer list, and you've got your first few customers, maybe even some big customers in that list. So I actually do help one of our customers to vet out potential startup partners. I've done that a few times. Mm-hmm. And what I often find is that after those first few iterations of the startup, they're not always ready to deal with the security requirements that some of the really big players might have. And I feel that's then when you kind of go from start to scale up, is then you start to be able to say, well, okay, well, can I handle my client's data in the right way, in the way that they want, right? It might be the right way, but in the way that they want, which may not be how you want to handle it.
The customer is always right.
Necessarily. Right. And then how can I deploy my stuff so it can work again within their own network or security requirements? And I feel that's an area that, and again, like it makes sense. Startups to start off with, you solve the 80% problem, right? You don't go after the hard 20% at the start, unless that's your whole model, of course, is to go after a very specific problem that 20% has. But I've noticed that as well with startups. Yeah, is the evolution from I have all my clients' data on my side of the fence and I deal with it in my way, which is secure, to I can handle my clients' awkward and fidgety requests that often arise from the security perspective.
Yeah. So I think that refers more to maybe like our side of the world in the sense of like DagsHub, like building tools for ML teams. But I'm talking maybe about the startup that is building a product with machine learning as part of it. So sort of acknowledging that in some aspects, ML is the same as dev, but in others, mainly the data and the fact that you need to do ops for your data. Now, I guess now you have data ops as well. So everyone is maybe familiar with that, or data-centric AI or whatever. But the idea that there is going to be like ops requirements for working with data in such a way that is connected both to development, because you need to train the model on real data, and then on production, because you're going to get another set of data points to perform inference on. And that's sort of another set of considerations that you should probably at least give some thought to, even if you're not solving them in the first iteration robustly or whatnot. But yeah, I totally agree.
Data is hard. And it doesn't sit still. Like code sits still, right? If I deploy an application, it might have bugs, right? But it will do what it's meant to do forevermore, right? Assuming that the inference doesn't break down. Data, just it's like it fidgets, it moves, it evolves. COVID happens, and suddenly all your models break because people's behavior is different. But that's also what's fun, right?
Yeah, it's more challenging, and I also think that in a sense it's more human, right? Like the changes are many times because it reflects the real world, which is not static. So, so in that sense, it gets us closer to reality than just like old school coding. But yeah, but it does have its challenges. So I guess this is a good segue into my next question, which is like, what do you think is the most interesting topic in machine learning right now, and why?
So I mean, honestly, I know it's cheesy, but well, from the kind of more what's on the research frontier of ML itself, I think for me the most interesting things right now are the emerging areas of responsible AI. So how do we use machine learning systems responsibly? What should those tenets be? Like how should we assess machine learning systems around equitability, fairness, explainability, all of those kind of things? I think that's increasingly important, right? Because one, I feel the public who aren't data science, they don't always trust this AI thing. Now, part of it is what I've seen in the movies, right? Science fiction movies and what have you that can sort of affect us. Parts like Elon Musk and what he says about, killer robots on the horizon, some of those comments that he's made. But also just like what we see in the media as well. AI systems used by authoritarian regimes or even misused by, by groups, here in America. Or I'm sure in Israel there's similar stories of models being both used for good but also used for less than good than good things, or even the classic cases of like models that make racist remarks, or in the testing phase, on court, the fact that the model was going to misclassify people of color in unfortunate and racist ways. So I think that's a really interesting area for me because one, it will help one is very in my own work. We do a lot of work with like state and government agencies here in the States at Catapult, and that's not even negotiable for them, right? They need to know they're doing the right thing for their constituents, because if they don't, there's very real political backlash off of it, which they won't tolerate, and rightly so. But there's also a level there of just the general public trust, right? If we can prove to the public that these models have been vetted, and or that we can vet them, and we can start to minimize the number of those instances that get into the newspapers, that will also help to, I think, increase the public trust and therefore help more adoption of these technologies, which are incredibly powerful. I think like all powerful technology, right, can be used both for good and for ill. I think we should make sure that we use it for good, and that we as data scientists are thinking about genuinely how do we do the right thing, or just I can build that model. Should I build that model?
I think that this is like a whole other topic. We should probably at some point do an episode which is just dedicated to this in the podcast. Like my feelings about this is, first, there is this aspect which I agree with, is that like machine learning is a tool, and so you will have like good actors that use it for good and bad actors that use it for bad. We should try to limit the second type of usage and empower the first type. And I think that's definitely true. I think that sort of when you take this into the more, and then there's the trust issue, which I totally agree with. And I remember like a few years back having conversations about like, what is the bar for autonomous cars in which people like the average Joe will trust an autonomous car over himself or someone he knows. And I think that you could argue that for good reason, we set the bar significantly higher for these ML systems than we would for a human, because I like the argument for like autonomous vehicles that if you're going to cross the street and a car is coming and it has a driver, then you'll try to create eye contact with that person. And then when you do that, then your assumption is that they see you. That's not always true, unfortunately, but there's the human aspect of creating this bond, creating this connection. And if there's no driver there, then you just can't do that. So you don't know if the car sees you or not. So you have to either wait, or I also read like the other option is you just cross and you know that the car is going to be better than the human, so it's going to stop anyway. But if,
all the old like trolley problem, right, for autonomous vehicles. You know, like you've got you're a passenger of the autonomous vehicle. You've got a bunch of kids in front of you. You know, and either you plan for the kids and kill them all, or the car crashes and kills the passenger. Which one of those two should the car be programmed to do if there's no choice? Yeah. Right? And if you know it's programmed to kill the passenger because you kill fewer people, would you ride in that car? You know,
I feel like my personal answer to that is yes, because it seems like such a rare case. But I guess like this is a good point, because in one sense, and I'm genuinely asking this, like I don't feel knowledgeable enough in this area. Like when you bring this over into the technical aspect of like, what does it mean to build a fair model? What does it mean to have an unbiased or sort of a model that can handle bias in a reasonable way? Like I know that there is a lot of interesting work done. I know that Hugging Face is doing some work in their big science project on this. And I know, like, let's say the parts that I do know is explainability is like a big issue, like understanding why models make decisions. That's a very sort of technical side of this. And once we do better on that, then we can address some of these issues more efficiently. And then the other part is like logistics. Like you need to make sure, if you want your model not to be biased, you need to make sure that you're providing as unbiased a data set as you can. So collecting that relevant data is also part of this. But I'm curious if you think that there are other ways or other research avenues that you've heard about to make models, again, fair, less biased, or something like that. And like, again, let's say from the perspective of I'm a data scientist or an undergrad, and I'm not sure what I should be studying to take part in this important battle.
Yeah, and you know, the fairness question is a challenging one because also like, what do we mean by fair? Right, that will depend on who you ask, which is why I don't use the word ethical around this, because ethics is very personal. I think responsible, we can define what that looks like to be responsible. Mm-hmm. And I think to have that, you know, at least we say you should consider these 6 or 8 things to be responsible. To be ethical, you know, what I deem ethical might be different to what you deem ethical. Mm-hmm. Which might be different to what somebody, you know, say in China deems ethical. Those could look very, very different. And so, and the irony with fairness, right, is that you can create an unbiased data set, but bias is encoded in all kinds of ways, right? And the classic one being, you know, in the US, race is often encoded in zip codes. Yeah. Right. So you might remove race from, you know, the data set, but it's still kind of there in zip codes. Or, you know, in many countries, you know, we encounter the fact that, say, black people get sentenced harsher in the criminal justice system. Mm-hmm. Which means that a machine learning model would see that and might make the incorrect assumption because it lacks lacks causal reasoning. Mm-hmm. Or hasn't seen race. It makes it draws a decision with people and with harsh offences, which is not because the person is likely to be, say, to commit a crime. They're likely to be convicted or more likely to be given a harsher sentence. And there's a large bunch of evidence on that. I'm not just, you know, spouting that. Yeah. There's a number of papers that would support that assertion. So it's hard to even build that data set up. And the irony is that there are some ways and some packages that you can use to actually, you know, in your validation set, actually validate against certain, categorical fields. Like you could say, you know, have a race field if you know it, then you actually could see, you know, what does my false positive rate, my false negative rate in particular look like against those different, those different markers, right? Even if the data itself is blind to that race, if you have it, you can use it in the validation to check for that. But that also leads to the challenge, of course, you know, should you even be looking at race at all? Right? Now, should we even be having that data available to us? Because if you have it, you might choose to use it in ways that are nefarious. So it's kind of a chicken and egg thing almost, right? You know, we need this to do this. But if we have this, we might do something to almost like unbalance that. I think there are a lot of the work that's being done in causal machine learning. I know that some of that there's been promise. And I'm by no means an expert in causal machine learning at all. But I'll just preface this by saying I read some papers on it. That's the limit of my knowledge on this. But there appears to be some nice things coming out of that might help towards some of these fairness things, right? We can look for why things are happening within our machine learning models. Then we might want to unpick some of that kind of, fairness things, right? If we could see that, oh, well, this is happening because somebody is, say, black versus white, well, that helps us say, well, there's definitely a bias here in it. Whereas, with the way that most models are built, using more correlations or, just basically pattern matching data onto outcomes, it's hard to pick out those unless we are actively trying to, and we're humans, right? We have our own biases and we make mistakes. So it's an interesting field to be sure, and I think it's one that I would like to see it gain a bit more traction. I still feel that some of the sexier areas like NLP and CD get a lot more attention still. I see a lot of papers out in those areas, and I do in the machine learning section, but I would like to see a lot more coming out of that. Although, of course, it can also lead, as we've seen again in the media, some awkward questions to be answered for some of the big players when some of their own researchers start to produce papers on these things, and whether they themselves are perhaps abiding by the best standards that they could be.
Yeah, I think that the best outcome in my opinion, for a field like AI fairness is to have rigorous standards that we can actually evaluate and apply on a technical level. And I think the further we are from that, first, in a sense, the harder it is for everyone, but also in the sense of being a draw for people to join in the field. The further it is from something practical, the harder it is to maybe, again, from an incentives perspective, you want a job afterwards. There's going to be less jobs for people that don't have the hands-on experience of actually building something. So I think the closer we are to having, and I think explainability and causal relationships in ML are probably the places that are closest to application. And you just this now caused me to think that I should ask on LinkedIn if someone knows someone that has causal models running in some context of production. That would be interesting. So we'll see. Maybe we could get someone on the podcast as well to speak. But I agree with you. This is super interesting. So another part of this is machine learning in production. What is the if you had to choose one challenge in that process, what would it be?
So the biggest challenge that I run into with this is differences between, and sometimes big differences between how a model is built in development and the way it runs in production. So this would be, I guess, this idea of offline online slippage, right? So, you train your model well, you've built a good data set, and of course you put it to production, it completely bombs, and you have no idea why it's bombed. It validated great, everything looked fine, and then you realize that your real data is, for a reason different, maybe substantially different from what your dev data looked like. But that can also be the way that you did it, because dev data is usually a batch dump, right? You get dropped some database, some CRM data, whatever it is, right? And that's there, and that's now immutable. Maybe it gets a weekly update, whatever it is, right? And then in production, you're running a real-time streaming model on the same data, right? The same data points coming in, but they're now streaming in real time. That's a very different kind of situation to what you had, in your dev environment. So even assuming that you've done all the right things around timings and looking at gradual changes in your examples rather than just when they finished, all the classic errors that people can make. Even that difference between just the raw way the models are running in production compared to how they're running dev can also actually have an impact sometimes on things, or even you haven't anticipated that you might be getting 100 examples at a time coming in, and you haven't built out your deployment to be able to handle that, because you were told, we'll have 1,000 a day. Oh, great, that's on average one every 3 to 4 seconds. Fabulous. And then you get told, well, actually, they're going to be 100 at once in some batches. So I say, that is figuring out how to account for that is quite difficult, especially when we talked about that earlier on, right? With this idea of the production data, right? The sacred production data. How do we get that back into dev? Because in a lot of traditional software engineering mindsets, prod data is prod data is prod data, right? And it does not touch dev.
Mm-hmm.
But of course, because data evolves, if you have your dev mutable and your production changing and evolving over time, your models will drift pretty quickly.
Mm-hmm.
So then how do we educate maybe software teams that are thinking in normal software terms about how that kind of how ML production is similar to and is different from a normal software engineering production situation?
Yeah, there are some good courses popping up, which are probably not a substitute for actually getting your hands dirty and experiencing it firsthand, but might give you some clue. Like you have a full stack deep learning, which is nice. It covers a lot of at least the theoretical parts. But I guess your experience is, again, more in the trenches of how this actually looks like. So I'm curious first if there are processes. So we spoke about like security, that's one issue, and we spoke about education, which is another issue, and those are like related because you need to educate people about like how security looks like in the world of machine learning. Maybe we'll have some ML sec developers in a few years as well. But the sort of is there tooling and processes that you have put in place in your projects to make this transition smoother and more efficient?
Yeah. So we, as I said earlier in this podcast, we are an Azure consultancy, right? So we are, we're Microsoft linked, and so I'll talk about what we do in Azure, of course, does equally well to other cloud providers as well. But we make essentially use of the actual platform services within Azure, and these are nice because these have a lot of the parts of the problem are already solved, right? Yes, the whole process is maybe a bit custom and needs some more IP around it, but often the little components are solved problems. So by using platform services, we can make use of all the solved problem parts in order to make things much, much faster. So one example here is, for the vast majority of projects, I know Docker, I can build my own containers. I don't need to, right? So at Azure ML has a set of pre-built, pretty robust ML containers that you can use to deploy models to endpoints via a couple of lines of code. So I can take a model that's in a model registry, basically Git for models, right? And I can literally take that reference and deploy it out to a Kubernetes cluster in 2 lines of code. That when I first learned that 2 years ago, that blew my mind. I was like, what? So I think making use of those platform services to do that. We use pipelines and Azure DevOps. Again, similar to this, you have GitHub Actions. GitLab has I think GitLab hooks. All the big Git providers will have some kind of DevOps pipelining technology, or even things like Jenkins or Circle CI from the open source world. We'll do similar things. Again, a lot of those, all you do is bring your own YAML files, like the configuration files for these pipelines, and then it will execute most of the stuff itself without you having to do all that much of the hard graft to make it happen, right? These tools are built to manage that process for you. So yeah, just using as much as I can of the platform services wherever I can in the cloud providers, I think is the main kind of piece of tooling advice I would give. Again, that can vary based on what platform you're using and what they can actually do. But we do very little bare metal IaaS work, if any at all nowadays, because that just adds overhead to you as the developer. You've got to then build things out from scratch. It adds overhead as well to maintain and manage those services. Like the last thing you want to have to do is to have data scientists deploy a model and then spend half of their time, their expensive time, maintaining it, monitoring it, checking in on it, right? So if all these services exist, you have to do the work to string together, with whatever blueware you need. And that to me is that's what's helped me overcome a lot of the issues that I would have had 3, 4, 5 years ago, and getting these things more smoothly into the production environments.
Yeah,
there's always exceptions, of course, to that rule, but
Yeah, you always, I mean, the advantage of, like you say, stringing the tools that you need together is that you sort of provide the glue. And that means that if tomorrow you need to add another tool or swap out one of those tools and you did a good job stringing them together, that should be significantly easier than taking something which is like end to end, very rigid. You have to use it as is, use it or lose it. And I think sort of like we're at DagsHub, we're not sort of limiting ourselves specifically to one cloud provider, but I think in general that's our approach. That's what we recommend as well. So it's fun to get to the same conclusion from different angles. I think that really you want the benefit of modularity. You want the benefit of having something which is tailored to your needs, but you definitely don't need the sort of task of reinventing the wheel. So look for tools that solve the problems that you have and then try to connect them instead of building it from scratch.
One thing that I find that a lot of data scientists, again, this probably comes from being from academia, a lot of them, I actually see still quite regularly, is people saying, yeah, but, what if I want to move to cloud providers, right? I don't want vendor lock-in, right? I want to, be able to just move my stuff from A to B. And I'm like, I hear that, and it's a valid concern. But I think, especially if you're at a company, if you're a startup and you're maybe early stage and you aren't quite, established yet, and you might want to quickly pivot to a different place for some reason, that's there. The minute you're at like a Fortune 500 company, like the effort required to move from Azure to AWS is enormous, right? Yes, there are reasons for doing that, but you as a data scientist will not have that call. Right, that's not your that won't be your call. That'll be IT's call to make, or leadership's call to make. Either go multi-cloud or to transition. So I'm like, your odds are you're going to be using these tools for a long time, right? Yes, you might want to switch out third-party tools, but a lot of platform tools, you're probably going to be using them in that environment for a while. Mm-hmm. So why not make your lives easier? So I guess, I like the idea of, I like open source as much as anybody else does, and I use it extensively, but just like isn't open source, you've got to pay for it. If it saves you a whole bunch of time, I think it's still worth doing, even if there is some level of vendor lock-in.
Yeah, I think, I agree. I think it's a matter of, like everything in life, priorities. It's not worth saying that you're multi-cloud or hybrid or whatever if it takes you another year to develop, or probably not worth. Again, depending on the use case, but you need to know what your priorities are, and a lot of times, I guess one of the challenges is you say your priorities are one thing, but we behave like they're actually something else. So we need to make sure that we're sort of we account for the priorities that we say we want to put on top. So I guess we're nearing the end of our time. I wanted to ask you, I guess for the listeners as well, if there are any tools that so we mentioned Microsoft and Azure and everything, but are there any tools that you use and sort of love that you would recommend the audience try out as well? They don't have to be data science related.
Yeah, so then I was actually pondering this, and the one that I really do quite like now is Visual Studio Code. Mm-hmm. So, for a long time I used Atom at first, I moved to PyCharm, I've used Sublime, and I now started using VS Code, which, yes, it's Microsoft, but it's open source, so it comes from their open source arm, so it's free to use and it's completely open sourced. Anyone can develop like plugins for it and stuff. And I found it to be quite nice. I mean, one, it helps my own work because it has Azure native plugins, which helps. But also, like, I just find it to be a very nice, like, lightweight. It's not a full IDE, but it's nice. It's lightweight and it's very customizable. And even like I can run notebooks in there, right? So I can have it has a lovely notebooks plugin, so I can just have my notebooks in there. So I can have my notebooks with full like linting and stuff in them. Which Jupyter itself doesn't always have that, or you got to install some weird plugins to Jupyter Lab to get that. Mm-hmm. So I've been using that a lot, and I quite like that as a thing. The other thing as well that I like, so again, Microsoft Shop, we kind of have to use Windows computers. Windows is not for data science work where more used to Linux, the most ideal thing to develop in. So I found Git for Windows, and Git for Windows has a lovely Bash emulator in it. So I actually can use that to write Bash and Linux stuff within my Windows environment and do all my Linux stuff in there. So it kind of treats, it's not perfect, but it's kind of nice. I know there's also Windows now has a Linux subsystem that you can install and use. I haven't played that for a couple of years now, but I'm kind of curious to give that another crack as well. Basically, how can I make my Windows system more like Linux? Is one of the questions I'm always asking myself on the tooling front too.
So I think if you're using Windows, Git Bash is awesome. I second that recommendation, and I also love VS Code. I think the Jupyter notebooks, all of the capabilities around Jupyter notebooks are pretty awesome for VS Code, and I prefer them also to using Jupyter Lab. So yeah, I second those recommendations. Are you currently learning or something that you've learned recently that you'd like to share with the audience and recommend as well?
Well, so I've recently, although I've been doing MLOps now for a while, I'm basically a team lead and architect, so I haven't actually necessarily done all the components of it hands-on. I've done parts of it, right? But of late, I've actually been learning to build my own CI/CD pipelines. So I was like, well, I direct my team to do that. I should then have to do it myself. And I had a client as well who needed it done. So I was like, yeah, I'll hop in there and learn that. So I've actually been learning how to write good YAML files, how to actually build and test CI/CD pipelines, to do promotions up the environment levels. And then more on the data science side, I've been learning few bits and pieces, but mostly math optimization. I've been trying to get a bit better at some of those things. Just again, partly because of client projects, but kind of digging into some operations research style stuff, and kind of getting a bit more knowledgeable on some of those parts of the puzzle.
Interesting. Yeah. So with respect to the CI/CD, this is a recommendation I'm stealing from my co-founder and partner at DagsHub, Guy. So shout out. And also, I remember a recommendation that he gave me when we were starting out to you're working on a system. That system is complex, and many times you need to work on just a part of that larger system. And a lot of people feel sort of content with knowing what they know, and sort of having the realization that things work around it, so that's okay. But sort of asking the question, what happens before I start working and what happens after I push my code is really, first, it's interesting objectively. The moment you start pulling those strings, you learn a ton of things. So if it's before, maybe it's about product user interviews and sort of understanding the needs that arise in the product. And if it's afterwards, how do we automate the build process, the deployment and everything? And you start pulling those things, first you'll be a better developer or data scientist or whatever your role is within the organization. You'll be more valuable to the organization, which means you could arguably advance further, get to better workplaces or get better offers. So it's good from the self-centered perspective as well. And it's really fun. It makes you a more well-rounded person, I think, within the industry, within what you're doing. So I think that's a great idea. And then I guess let's finish with recommendations for the audience. Anything books, podcasts, TV shows, or something else.
So I mean, the one book that I recommend to everybody that I work with is the Linux Command Line and Shell Scripting Bible from Wiley. I think learning Linux is, at least learning it well enough to use it. I mean, yes, don't become a full sysadmin unless you want to do that, right? But I think learning how to use the command line and shell scripting well it's an invaluable skill in data science, right? Just that fluency is super helpful. So I really recommend that. And then in terms of kind of in terms of learning, I actually kind of, because you could learn so much stuff, right? It's a huge field. I cheat. So I follow people on LinkedIn that I think are interesting, and basically I see what are they recommending, right? Because they've probably gone and done the hard work. They've probably gone and read all the stuff, right? And they've probably to do all the stuff that's good, say on the archive or somewhere else, and what maybe is more niche, shall we say? And so I kind of almost look down what are the filtered recommendations that I'm getting or seeing from certain kinds of people in the field, or people that I personally find like interesting kind of in the area. And then I will go and kind of read things that they've say, oh, this is interesting, or this is a good blog post, or this is a curious thing to go and learn about this topic. Then my biggest kind of recommendation in general in this field is, ask lots of questions, right? If someone comes to you with an idea for a project, your business stakeholder comes to you, I've got this great idea for a project, right? The first thing that you should be doing is to ask questions like, okay, great, why? How will we measure that? What does the success look like for that? And then just digging deeper and deeper over the next few weeks to just asking lots and lots of questions to make sure that one, you can build, deploy whatever you want, but also is it worth it? Is it valuable to do so? I think a lot of people, partly because of the kind of people this field maybe attracts, maybe a bit more introverted, and kind of might find it harder to ask those kinds of questions. But if you can get out your content and just ask, if the CEO is asking to do something, still ask those questions, because it's better to do that up front than to build the right thing well. Well, and as a startup, right, you know this very, very well, right? You want to ask the right questions of your users first. You're building the right thing to actually solve a real problem, rather than building what you think people want and then with no market at the end of it, right? So asking questions is a very, very good skill to have.
It's like the old school version of Googling stuff. You need to. It's the critical skill that people underestimate. So I definitely agree with that. I think it's valuable, and most reasonable human beings see the value in that. So if you're worried about asking questions because maybe someone will think that you don't know something or aren't as good at something or whatnot, then I would encourage you to think again and try. I think it's a good way to learn more and be better at what you do. My recommendation is more pop culture, I guess. I don't know. I just finished reading a sci-fi book that I got for my birthday, which is called Hail Mary Project by Andy Weir. It's the same guy that wrote The Martian. He takes his writing style of doing sci-fi, but trying to limit the places where he's not adhering to the science that we know of, making that very limited. So taking into consideration a ton of things like gravity, chemistry, physics, chemistry, biology, stuff like that, with some caveats because it is sci-fi. It's really good. I read it in I think 3 days, and it's 400 pages. So I just couldn't drop it. So if you like sci-fi, you should read it. And that's it. So with that, Lee, thank you very much for taking the time. This was a lot of fun, and we should definitely do this again in the future. So yeah, thanks for joining us.
Thanks for having me. Appreciate it.
So bye everyone. See you next time. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.